If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in advanced level. So today we will be solving question number 13b, 14 and then 15. Okay, then let's try to solve these questions. Now if you come to 13b, if A, B, C are the three sets of complex number defined by this. Now you see the complex number. A is imaginary of Z should be greater than 1. So what is imaginary of this y-axis? So it is saying that the value of y should be greater than 1. That means the area A denotes, that is this area, the shaded area above y equal to 1 line, because y should be greater than 1. What is B? B, you can see this is a circle. It should be on the circle. Taking center as 2, 1, taking center as 2, 1, radius 3. Take a radius 3, draw the circle. So this is on the circle. This means it is on the circle. And this one we have to calculate what is C. Okay, the number of elements that C in A, B, C interaction. So what are the number of points? Till now, if you don't draw C, then all these numbers are in common, because it is also y greater than 1. It is lying on the circles also. They are asking number of elements of Z. So we have to find this one. So you see, if you see this one, this is nothing but Z. If you take x plus iota, take product, because the real part is root 2. If you take real of this one, so you calculate real of this one, x plus y root 2, which is nothing but a straight line, which passes through 0, root 2, 0, root 2. You know this is 2, 0, so it should go this way. So you have to be careful, because it is 2, so root 2, 0 will be. You have to something logical about while giving the coordinates. This is 0, 1, so obviously this will be going here. 0, root 2 will be above this one. So this is, now Z should lie on this line, Z should be above this line, Z should be on the circle. So you have only one point which satisfies this one. It is on the circle also, it is on the line also, and it is above y-axis also. So you have only one Z which satisfies, which are in these common sets, common to A, B, C both. That is option B. Only one will. Now if you come to 13b, let Z be any point on the A intersection B intersection C. That means what we have done, same continuation with this one. Then this minus this plus this lies in between. Okay. So you have to see what are the points they are asking. This is the distance between minus 1, Z, you can write it Z minus 1 plus I. So it is minus 1 plus 1. So minus 1 plus 1 I plot it here. And this is 5, 1 I plot it there. Okay, now you know that what was the radius of the circle 3. So it is 2, 1. So it is at 3 unit from here. It is at 3 unit from here. So it becomes a diameter. So once it were, now what they are asking, this was the common point Z. Z be the any point in the interaction. We found this is the point only which satisfies all three. Intersection of these three is only this point. So from here this distance, from here this distance, the square of this one plus square of this one. You know, if it is a diameter, it is a circle, this angle will be 90. So this square plus this square will be nothing but this square. And this is 3 plus 3, 6, 6 square 36. So the same way it is explained here. Now I think you can know. Here I have put in that value in the circle, whether it's satisfying or not. But here also you can see it will satisfy, because 3 unit from here is minus 1, 3 unit from here is 5. But you can put the point in the circle itself. This is the circle, you put the point minus 1 plus I. You see this side is 3, this side is 3, so it will lie on the circle. You put this point 5, I, 5 plus I, you put it there, it is also satisfying. So both these are on the circle. Now if you come to now 3 of this same question, if Z be the point again in the same point Z, let W be a point satisfying this one, then Z minus W plus 3 lie between what values. Okay. What they are asking, Z minus W plus 3. Okay. W is a all set of points. You can also check here, W is all set of points, which is 2, 1, again 2, 1, but radius is less than 3 here. So that means W is inside this one. So the distance between Z and that W lies in between. Why? Plus 3. Plus 3 we will do it later. Plus 3. So if W is somewhere in this circle, what will be the smallest possible point? It can be very near to this one. That means distance can be 0, but it will not be 0 because it is not equal to 3. It is just inside, not on the line, on the circle. So W suppose is just inside the circle here. So the distance will be very small here. What is will be the distance? Distance will be 0 here. And what will be the farthest distance? If you go diametrically just opposite, again not on the circle, just below the circle. That means it can go up to 6 unit. It will not be 6 exactly, because it is not on the circle. So it will move from 0 to 6. This distance between Z minus W. These will lie between, it will not touch, it will lie between 6 and 0. So this one I told you. Now you know this one, what I told you. but they are asking you something similar to this one. Now this one we can apply the triangular inequality. This I know the difference between two complex number is less than the difference between mod of difference between them. Individual mod, this was the triangular law. Difference between two sides is always less than the third side. So you can know this one. So this one, now this range you know. So once you know this range, you can find this. This will be also less than that. So that means this will be also less than 6. So once you know this value, because this was the mod, I know which one is greater, I don't know. Z can be greater also W. If W is here, then W can be greater also. W is here, it depends. Z is from here to here. Mod Z is I know this much, but mod W can be anywhere in this. So this difference can be either way also. So that's why I've given this one. So this difference should be less than 6. That means it can go minus 6 to plus 6. Because mod of this one is 6, so this can go negative direction also. Z can be, W can be greater than Z also. So if you add 3 with this one, because you need to find this one, so this will be minus 3 to 9. So that is your option D. Now if you come to 14, Z is given is this one. This one is the Euler form. You can write it in this way. That is 6 theta. The value of this. So they have asked you to find this one. 1 to infinity up to Z to the power 2m minus 1 and theta equal to 2. Okay. Now if you open this one, it is nothing but if you go by Euler's method, then you will feel it because it is a GP. Every time if you change these values, suppose if you are putting m equal to 1, then it is okay 6 theta. If it is putting m equal to 2, then it is 6 3 theta. That means e to the power I 3 theta. If you put 2, then if you put 3, it will be 5 theta, that is e to the power I 5 theta. If you write it in this fashion, then you will feel that there is a GP series is here. Here I have used a formula. This formula is nothing but the way I derived that cos series, sine series at the end of the complex number. So that way. So without how many formulas you will know. That was for sine theta, sine, and here it is for odd values of sine theta, 3 theta, 7 theta, 9 theta, all these. So that's why no need to remember this formula. You just open it in GP series. It can be anything in the question first. So imaginary part of this GP series. This GP you know a into r to the power n minus 1 divided by r minus 1. What is r? E to the power I 2 theta, because every time you are multiplying e 2 theta, e 2 theta, e 2 theta. What is your first term? E to the y to the power. Number of terms is 15, because from 1 to you are going up to 50. So it is 50. So if you open it now, so if you take e to the power I 15 theta common, it is 30 I theta, so it will be 15, and here is nothing, so it is minus 15. So if you take product, it will be 0. Here also e to the power I theta, if you take common, it is 2. So if you take one theta common, another theta, no, then no theta was there, then minus theta. You divide both this one, divide by 2i. So this will be your sine theta, that is 15 theta. We have seen e to the power I theta minus e to the power minus I theta by 2i is equal to sine theta. So this is also sine theta. So now imaginary part, this one, this already no here if you take imaginary, only sine theta will come. It will be cos 15 theta plus I sine 15 theta. So if you take imaginary part, sine 15 theta will come. That multiplied by this one. So which is this one. Now you put theta equal to 2 degree they have given. So it will be sine 30 by sine 2. Sine 30 you know, half of 1 by 4. That is your option D. So no need to remember all this formula. You can go by GP series in the exam. Now if you come to 15. If z is equal to this one, be a complex number where x and y are the integers, then the area of the rectangle whose vertices are this. Okay, now they have asked you this one. So this one, if you see this one, you need to find the values of z. So you need to see whether you can factorize it or this one. So you have something to take common. So if I start with this one, so I can take this one as a common. Then, because I don't have anything to do with now this one, so I take the help of z is equal to x plus y. When you are helpless, you cannot do anything. Then you go to this one, this method, because you need to find something format, some type of solution of this one. So if you apply this one, you open it, then you will see that it is easy, because it is, and this is also easy, a minus b whole square plus a plus b whole square. So you can easily find it out. So you have this one. Now because this will be also positive, this also positive, and x and y are integers, so take the split a 175 and factorize it to the factorization. So if you do it factorization, then you will get it. So you will get only these possibilities 25 into 7. These are the possibilities, or 5 into 35. These are the possibilities. But because x should be integers, so it should be something of that. So that, because if it is 25, then it is 3 4 you know. If it is 7, then also you know it is 16 9. So it becomes easy if you take 25 and 7. So if you see this one, so you can write, you can split it into 25 and 7. You can do it other way also, 35 into 5, but that will not give you as beautiful integers x and y, because they have given you x, y and r integers. So here if you take this one is 25, so x and y are 3 and 4, that is 4, 16 and this one. So if you take this one is 7, so you can get it is again 16 and 9. 16 minus 9 is 7, 16 plus 9 is 25. So you will get good answer using this one. So you have to check a little bit which factor. Only two possibilities are there, 25 7 or 35 5. Okay. So that means your x is plus 4 minus 4, y is plus 3 minus 3. So you put all these things. X can be plus 4 minus 4. These are the extreme. They have told you the area of whose vertices are the roots of these equations. So it is 4 comma 3. So another one will be 4 comma minus 3, minus 4 comma minus 3, minus 4 comma 3. So what will be the area? This into this. So this is 8, this is 6, 40. If you like the video, then press the like button and please give your valuable comments in the comment section.